What does it take to get to the moon? The moon. Power. Speed. Determination. And a new generation of explorers dedicated to building a brighter future. NASA's new space program is called Constellation. Join the adventure at nasa.gov.
The Orion spacecraft is America's next manned spacecraft. So the vehicle is going to be capable of low Earth orbit operations and also capable of going beyond low Earth orbit. This new spacecraft design takes advantage of being able to do both. It's a very flexible design.
Orion serves a need for space station. It brings crews back and forth. It brings supplies, some supplies back and forth, some critical things with it. But the missions to space stations serve a big purpose for Orion as well. It's you don't want to take the new car out on the long duration road trip the first time out. So from a strictly Orion perspective, we get a lot of benefit from these near-Earth, low-Earth orbit missions to try out the spacecraft. When we go to a station, virtually all the functions that we need on lunar for Orion will be exercised. You need power generation, you need thermal control, obviously all the avionics, you need rendezvous and docking, which are critical, obviously, for a lunar mission where you're sending a module to the surface and then having to rejoin with it when it returns. So virtually every system that has to be used for lunar is used during those low Earth orbit missions.
The normal crew rotation on space station is getting to be right around 6 months. Crews will sometimes be a little shorter to that, but it's a unique opportunity in that the crews do stay for months at a time. As we all know, when you put a human into a gravity-free environment, it's a new environment for the body, and the body is a very plastic thing and adjusts. And so your bones start to lose bone mass. Additionally, your muscles also become weaker because you're not using them every day to fight gravity as you do here. And even your ability of the body to control itself from a sensory motor standpoint, how your brain controls the actions of your body, has all been developed against a gravity environment. When that goes away, your emotions have to be basically reset. The entire human research program that NASA is currently working with was very carefully reviewed to focus the efforts during ISS on answering constellation-related problems, answering exploration-related problems. For example, we are actively looking at pharmacological countermeasures to bone loss, to exercise and nutrition as countermeasures to both bone and muscle loss, and specific types of training for the crew to help manage their sensory motor problems. And so station is a unique opportunity to look at both how the human changes during that time and how, as a support organization, you have to adjust and support those people to allow them to function when they get to the place they're going to go.
In the Constellation program, we're going to the moon to be able to learn how to live there, to stay there, to use resources that are present to enable our missions and deal with these problems in a situation where the crew is further away from Earth. The Constellation lunar exploration scenarios fall into two different categories. With the Altair lunar lander, we can set a crew of 4 down anywhere on the surface of the moon and sustain them for 7 days, whether it's to deploy a telescope or perform a geologic expedition. There's another configuration, another variant, if you will, of the Altair lunar lander, and that's called a cargo lander. And this Altair cargo version will enable us to deliver large pieces of a lunar outpost infrastructure, like a big habitat or several pressurized rovers or a large power generation capability. All the necessary building blocks of a lunar outpost, and this outpost will sustain a crew of 4 for missions up to 180 days. So the Altair lunar lander will be the mode by which we bring the crew back and forth. It will take the crew there, wait for them for their 180-day stay, and then be capable of bringing them back to the Orion spacecraft in low lunar orbit.
Human exploration of Mars is different than any mission we've conducted before. During Apollo, the missions were fairly short, 3 days there, 3 days exploring the surface, and 3 days coming back. But with human exploration of Mars, it's much more difficult. It'll take about 6 months for the crew to get out to Mars. That's about what we do on Space Station in a crew rotation mission, so we're learning a lot there. Once crews get to Mars, they'll explore the planet for about 500 days, waiting for the proper alignment between Earth and Mars. And when that alignment occurs, it'll take about another 6 months to come back. So overall, it's about a 2.5-year mission. Again, 6 months out, 1.5 years there, and 6 months coming back. Future human exploration of Mars will be a stepwise progression, starting here on Earth analogs, learning how to test systems and how things operate. Constellation systems that we're developing today will feed in very nicely to future human exploration of Mars. Launching the Orion capsule fits in perfectly in terms of delivering crew to low Earth orbit, up to 6 crew. The space station fits in terms of being a very vital test bed for human operations in space. Future systems that we're going to land on the surface of the moon, the habitats, the pressurized rovers, the power systems, all of those elements will be, if not identical, very similar to the systems that we'll actually take to Mars. We don't have a firm time frame of when we might send humans to Mars, but we know it's going to be a few decades in the future. That means that today's children who are just entering elementary school may actually be the actual astronauts who fly those missions. So inspiring children to pursue math and science is very vital that we keep that going so those children can actually be the ones that explore Mars.
You know, that's one of the tasks that NASA has for humanity, is to start to extend our presence off this planet. Unlike the past, where many of the children did not have an expectation that humanity was moving in that direction, the current generation does. It is part of their culture. And so I think we'll be well positioned for that as long as we prepare them for all the things that are necessary, that, you know, we commit to education and preparing them for the skills that it's necessary to go there.
I think a lot about the longevity of the Constellation program. I have a 5-year-old daughter. She has her little Orion mock-up, like many of the children of people that work in the Constellation program. And so I think a lot about the legacy that we leave in these early missions and how that will evolve over time and be the space program that my daughter will inherit and her daughter and son will inherit someday. I think that's where a lot of the pride in what we do is that we feel like we are, in fact, the folks that are keeping that alive for our children.
So we're now looking at a process of human movement out into the solar system, which has more than just technical implications. It has sociological implications in terms of technology development, in terms of inspiration of youth, in terms of demonstrating leadership in the world, in terms of creating new opportunities for economics and economical development in space, and scientific implications.
NASA's new vision for space exploration returns astronauts to the moon, setting the stage to travel further, exploring Mars and beyond. To succeed in these new journeys, we'll need new tools, new technologies, and new methods for exploring. But all of these elements will need to be tested before we travel to those far-off places. This is the job of Desert Rats, Research and Technology Studies, to create a dress rehearsal on Earth for the space missions of tomorrow. It's dawn in the desert, and the RATS team is already hard at work on another field test. Similar tests took place during the Apollo lunar program. The experience proved invaluable in figuring out the capabilities and limits of equipment prior to them being used on the moon. NASA's new space program is called Constellation. For this new era in human exploration, missions to the moon will be longer and more complex than Apollo. To prepare, the RATS team is testing a new generation of equipment, taking it out of the comfort of the laboratory and into the rugged and punishing environment of the field.
Testing in what I would say is a representative analog setting and kind of a desert setting, for example, in a remote location, pretty much gives us a representative terrain situation that we would probably encounter on the moon and Mars without actually going to the moon and Mars.
The field is dirty, the field is hot, the field is cold, it's rough, it's bouncy, it's sandy, it's dusty, it's all the things that you don't have in the laboratory. So you can build a piece of equipment that works just great in a nice air-conditioned, carpeted laboratory. You get in the field and it breaks. And in some ways, braking is what we wanted to do because we'd rather have it break here than in space.
So what exactly does Desert Rats bring to a field test? Everything we want to use in real exploration.
Well, there's three main elements of RATS. There's spacesuits, robots, and tools. And we test them all together here on Earth in order to save time when we do go to the lunar surface.
Like a miniature spaceship built for one, the spacesuits used today by astronauts are built for zero gravity, perfect for tasks outside the space station in Earth orbit. But the RATS team knows the astronauts face a different set of circumstances on the moon and Mars. The suited astronauts will encounter some gravity, and they will need to do the work of a geologist, traversing on foot across dirt, rocks, and inclines.
On the surface of the moon, they'll have to walk around, they'll have to bend over and pick up rocks, they'll have to sit on rovers, and they'll need a lot more mobility than they need currently. So there's a lot of new requirements that we have to add to the new spacesuits.
The lessons learned by the Desert Rats field tests help drive engineers toward a better suit design.
What I know about doing lunar surface EVAs, I've learned from going to RATS. So I've learned a lot about how the suit moves, what it's capable of, what I shouldn't expect it to do, and then all of the different interfaces I'm going to have to make sure that it interacts with while it's doing its job.
You have more cooling at Sydney as well?
In addition to knowing what to wear, Desert Rats is helping us decide what tools to bring for planetary exploration.
Some things are still pretty much the same. I mean, a hammer is a hammer is a hammer. And the only thing that changes is how well you can wield it and how heavy it is when you hit the rock in front of you. But we have expanded to more tools. We've looked a little bit at some of the more advanced analytical capabilities you might have in the field. But one of the other things we've really done is how do you get to where you're going? You know, using rovers, do you walk everywhere? If you walk everywhere, is there an easy way to carry stuff?
The RATS team also tests habitats, airlocks, science trailers for analyzing samples, communication links for voice and data, and other necessary exploration gear. But alongside the human explorers will be some other devices that can crawl, see, and move on their own. Some might think that when it comes to exploration, robots are sent first and then humans later, working separately. The Desert Rats team is discovering the two actually work better together. No longer the stuff of science fiction, the latest generation of robots is being tested in the field to see how they can best serve as assistants in the exploration effort.
The benefit of having humans and robots work together is to maximize their efficiency. There are some things humans can perform more quickly than a robot could, and there's other things that a robot could do more efficiently than a human can. Some of the more mundane tasks that are very repetitive.
The use of robots is just one of the many mission activities that Desert Rats has conceived and demonstrated. From analysis of samples using a mobile science lab, to nighttime exploration, to testing the recharging capability of the suits, Desert Rats is writing the book on new planetary exploration. Desert Rats is also reaching out to the future explorers, inspiring students through educational events, showing them how math and science help us reach for the stars.
We need to engage the public and get the younger generation interested in what we're doing and get them excited, because they're really the next generation of explorers that will go on to other planets.
Through Desert Rats, the engineers who design robots, spacesuits, and all the tools needed for exploration work together as a team, talking face to face, problem solving, and answering the tough questions about exploration. So when humans do return to the moon, the knowledge of how to explore will travel with them. Knowledge gathered here on Earth by the Desert Rats team.
You know, there's so much you can only do sitting behind a computer typing up some dream requirements, but then you have to put it into effect. You have to develop that piece of equipment or that scenario of activity and then perform it somewhere in a relativistic type environment that's typical of what you might find if you go back to the moon and on to Mars. So hopefully this data becomes very meaningful in the sense of shaking out the true requirements.
It has been 3 short years. NASA began a journey to create the next space program, one that would take us beyond Earth orbit, returning us to the moon, and extending our reach to Mars and beyond. No longer just a program on paper, Constellation has projects, hardware, and software in every stage of development. In just 3 years, Constellation is ready for its first test flights, launching a new era of human space exploration. Through the Constellation program, NASA has taken a vision, the idea of exploring beyond low Earth orbit, and strategically created a detailed space architecture, a plan to make the vision a reality. Constellation begins by conducting missions to the International Space Station, using the Space Laboratory as a destination and proving ground for a new generation of spacecraft. Next, Constellation sets its sights on the Moon, exploring the lunar surface in ways never before possible. Unlike Apollo, which was limited to the exploration of the lunar equator, Constellation's architecture will allow astronauts to explore anywhere on the Moon, staying twice as long as the Apollo missions, with twice as many crew members. This extended exploration capability has been a driving force for all of the Constellation spacecraft designs, which will be able to lift more mass and travel farther than any previous spacecraft. The Orion spacecraft is the crew exploration vehicle for Constellation. Orion borrows its shape and aerodynamic performance from Apollo, saving time and design work as well as reducing risk. However, the spacecraft is greater in size than Apollo, featuring updated computers, life support, electronics, heat protection, and other systems. The development of the Orion spacecraft is well underway. Several test articles have already been constructed and are being evaluated at NASA centers and engineering centers across the nation. Parachute drops have been conducted to test how Orion will return crews safely to Earth. The launch abort system, capable of pulling the spacecraft and its crew to safety in the event of an emergency, is set for a full-out test in 2009, while the rocket motors used in that system have already been evaluated in preparation for that flight test. The launch vehicle for Orion is called Ares 1. It features two key components utilizing legacy hardware. A solid rocket booster similar to that used by the Space Shuttle comprises the lower stage of Ares 1. The upper stage features a J2X liquid fuel rocket engine derived from an Apollo-era rocket engine. Using these proven systems, the Ares 1 will get the crew into Earth orbit. The Ares 1 project completed its preliminary design review, the first such milestone in more than 35 years for a U.S. rocket. A test flight article of the Ares 1, called the Ares 1X, is slated for launch in 2009. The test flight will be a major turning point in the program, providing essential data on avionics, thrust vector control, and other systems, validating computer models by actually flying a full-scale vehicle. In preparation for the test flight, segments of the Ares 1X have already arrived at the Kennedy Space Center for assembly and processing. In addition, tests continue in all facets of the Ares program, from computer simulations to wind tunnel tests to engine test firings, providing engineers with the best information possible on how the crew launch vehicle will perform. Ares 5 is the heavy-lift cargo launch vehicle. It will carry the lunar lander and other large components into space. Again, using legacy hardware, the Ares 5 will utilize solid rocket boosters during liftoff to help get the vehicle into orbit. The crew on board the Orion will rendezvous with an Earth departure stage of Ares 5. The entire stack, Orion, the lunar lander, and the Earth departure stage, is then sent toward the Moon, once again using the J2X rocket motor. Because several key components of Ares 5 are the same as Ares 1, much of the engineering work being done applies to both vehicles, from solid rocket booster tests to firings of the J2X rocket engine, which is the first component to pass beyond the critical design review phase. In all, the Ares 5 will be able to lift more mass than any previous spacecraft. Studies have already been conducted to see how this versatile craft could be used to launch scientific payloads, satellites, and even space telescopes. The Altair lunar lander will carry 4 astronauts to the Moon. Larger and more robust than its Apollo predecessor, Altair will be able to land anywhere on the lunar surface, even the lunar poles, previously an unreachable target by manned spacecraft. The Constellation program recently completed a lunar capability concept review, demonstrating how the Altair lunar lander will reach the Moon and later help build lunar outposts. Spatial studies by engineers have helped determine the interior layout of the lander, driving out better ergonomic designs for the crews who must live on board for extended stays on the Moon. Additionally, work has already started on testing and improving all the gear needed for exploration in the Constellation era. From lunar rover tests to planetary spacesuits to tools, NASA is taking hardware out of the laboratory and into the field to achieve the best possible designs. In addition to the hardware development, NASA facilities are updating their capabilities for Constellation. New launch pads, lightning safety systems, firing rooms, factories and testing facilities are being completed to accommodate the new wave of exploration requirements. Most importantly, the Constellation program is about people. From around the nation, all NASA centers are engaged in this new exploration effort. Problem solving, building, testing, and taking on the challenges of human space exploration. It is an effort that brings together generations, those who experienced the Apollo moon landings and those who came after. Together, they are working on a brighter future, looking to return to the moon and go beyond. As the Constellation program leaps off the drawing table and onto the launch pad, a new chapter in exploration history is being written, one milestone at a time.
For those who haven't read the plaque, we'll read the plaque that's on the front landing gear of this LEM. There's two hemispheres, one showing each of the two hemispheres of Earth. Underneath it says, "Here men from the planet Earth first set foot upon the moon, July 1969.
Looking now, baby, see them rockets in the sky. Somewhere there's someone steady staring upwards as they die. Some folks is frowning, doubting, but we'd never play around. Spike a holy ball of fire from the heavens to the ground. Yes, we're looking for a crowd pleaser, rockets in the sky. Yes, we're looking for a crowd pleaser, lit up like the 4th of July. Beautiful and deadly like a devil femme fatale. Got people across our nation screaming, can you hear us now? No stranger propaganda, we're all suckers for a show. Grab a weapon at the door and leave behind your moral code. Yes, we're looking for a crowd pleaser, rockets in the sky. Yes, we're looking for a crowd pleaser, lit up like the 4th of July. Yes, the waves have all crested and we're all in a daze. We're all down in the valley, just living through the haze. Seems history is ended, time to cash in those chips, but you ain't seen nothing yet. The fuse has just been lit. It's a road runner, air grabber, out on a cruise. It's a working man, a ridge runner, yeah, it's burning up the blue. She my kissing cousin, wild-hearted, but her aim is true. Top up window, flashing my babies, howling at the